Hi students, welcome to this video. Today we're going to be going through the first subtopic of Module 1 of the HSC Engineering Studies syllabus, and Module 1 obviously is Civil Structures, and the first component of this module is the Historical and Societal Influences part. Now this is probably the smallest and easiest topic to understand for any of the four modules. All four of them do have this, and it's relatively easy to pick up. It's all theory-based, there's no real engineering applications being applied, it's more theoretical. Looking at this subtopic, we can see that there's specific points that we have to check off. First being historical developments of civil structures, second being engineering innovation in civil structures and their effect on people's lives, construction and processing materials used in civil structures over time, and then environmental implications from the use of materials in civil structures. Now, these can further be emphasized through outline the history of technological change and apply to civil structures, investigate the construction processes and materials used in civil structures from a historical point of view, and then critically examine the impact of civil structures upon society and the environment. So in today's video, we're going to be covering all these dot points and covering this entire subtopic of historical and societal influences. So let's get started with the first thing, which is the historical developments of civil structures across time. Now, for this part of the topic, it is not important for students to know key dates or key engineers or key specific structures being made. It's more just to get a general understanding of the innovations and changes across time. So looking at this, we can see the first part is that from 10,000 BC, primitive bridge and suspension bridges to cross rivers and ravines. That was the basic purpose of a bridge back in the day. It was to get from one side to the other of a simple river. The Greeks perfected the beam bridges. The Roman engineers designed arch bridges, which were more stable and secure. Arch bridges did not impede water traffic, so it went over rather than going straight through it. With the fall of the Roman Empire in the 5th century, medieval arch bridges that were made were not as efficient. In the 16th century, truss girder bridges were made, which could go longer spans and were relatively safer. In the 19th century, modern suspension bridges were made. The bowstring girder braced by railway engineers, that's a specific type of bridge that was made. In the 20th century, the first box girder used for freeways. Now, it's not too important to know what box girder bridges are at the moment. This is a key case study that you will look at later on in the module when you're looking at material sciences, such as wrought iron, cast iron, or different types of iron. The box girder bridge is a specific case study that you will look at when it comes to learning about the materials in this module. And the cantilever bridges, limited impediment to water traffic. The Brooklyn Bridge, again, this is just an example. First suspension bridge to use steel cables. Concrete used as a building material for arch bridges. The Sydney Harbour Bridge completed in 1932. Cuts travel time to North Sydney. Tacoma Narrows Bridge failure leads to safer suspension bridges, and then sections designed to deal with wind. Now, again, this is just a general list of historical developments of civil structures. It's so important to know the key dates and the key names of all these bridges. I would highly recommend, however, to know at least one main bridge. And obviously, being a subject in New South Wales, it's probably best to know the Sydney Harbour Bridge relatively well regarding its materials, its design, and the type of bridge it is. Now let's move over to the historical developments of civil structures and what are the different types of bridges. So beam bridges, as you can see, this is a simple truss beam bridge over here on the right-hand side. So a beam bridge, simply a member that is supported in a way that the supports do not carry any longitudinal forces. Simply supported beam is a type of beam bridge, or a cantilever beam is also a type of beam bridge. Now, arch bridges only use compressive forces. Stone arches to steel arches to concrete. That's the development of the materials used for arch bridges across time. Stone arches were obviously used by the Romans back in the 5th century, and then it transferred to steel bridges, and then finally concrete bridges. And then elliptical bridges are another type. Then these are some examples of arch bridges over here. So this is the concrete one, and this is the cantilevered one. And then finally, we have suspension bridges, supports deck. So the roadway on the steel cables strung between support towers, cables in tension. So as compared to arch bridges, which use compressive forces, suspension bridges use tensile forces. So here are a few examples of suspension bridges that use tensile forces. Now moving over to the engineering innovation in civil structures and their effects on people's lives. We'll put a pause on the materials and first look at the impact on society and environment. So in terms of bridges, they're allowed for transport across rivers and ravines, improve traffic for human and animal drawn traffic, improve safety as well, and then less congestion in towns and streets. In regards to a specific example, the Harbour Bridge connects north and south of the city, cuts travel time, speed developments. But in regards to cost to society, toll bridges, financial burden. Obviously, building a bridge is not cheap, so it will be an impact on taxpayers as well. Extra relocation for people to suicide, that is also a risk that you have to think about as well. And this is probably a good answer to write down in an exam. And then high cost to build, financial burden to taxpayers, as we mentioned. Now, when it comes to answering questions like this in an HSC situation, a common example of it, a question would be a 2-marker that says lists society influences of the construction of a specific bridge. And a good idea of how many examples to write, each mark associates to a specific example. So for example, if it's a 2-marker and it said explain just the influence, it can be good or bad. You can give one good and one bad. So one good one could be improve transport for humans from one side to the other of the said bridge. And then a negative impact could be cost to society, high cost to build, financial burden to taxpayers. That will give you the 2 marks, and you can write in dot points as well. Because engineering studies markers are not too fast to see full sentences. You just want to see the correct answer in simple dot points. Now let's look at the influence on the environment itself. So in regards to costs, use of large quantities of natural resources for the construction of bridges and overpasses. So for example, timber, clay, mining quarries causes scaring of landscape. Fossil fuels to melt and work steels, iron. So the fossil fuels obviously leads to global warming. Storage of bridge materials at site may disturb natural environment. It's another key cost that we have to think about. Obviously, when you're constructing a large-scale bridge, for example, Sydney Harbour Bridge, you will have to store the materials nearby, which will obviously disturb natural environments. Metal bridges need constant corrosion protection, using finishes that may be detrimental to the environment. So obviously, having a bridge made of steel, you have to make sure that it doesn't corrode. So you will apply corrosion protection to it. You can galvanize it, add zinc or other coatings to it as well. And obviously that costs money and also will have an effect on the environment. Now in regards to benefits, using concrete is using an almost unlimited natural resource, sand, water, aggregate. Also with concrete, it requires minimum maintenance, so it won't really require, for example, the corrosion protection, which does damage the environment. Mining of ingredients of concrete has a minimum effect on the environment. That's another thing to consider since it's just sand, water, and aggregate. Use of composites and other advanced materials has resulted in the use of less materials with better structural results. High-strength steels and pre-stressed concrete have produced more attractive designs. So those are some benefits. Other ones that you can think about for the environment as well. Obviously, creating a bridge allows you to go from one side to the other, and it prevents the need to create roads amongst the ground, which again would lead to less deforestation overall. And also creating bridges such as suspension bridges that don't require pillars in the middle will not be disturbing the waterway or the water flow of natural water reservoirs. Now let's shift towards the actual key component of this subtopic. So far we've looked at this historical developments of civil structures, and then engineering innovation, civil structures, and the effects on people and the environment. But now let's actually look at the construction and processing materials used in civil structures over time, which is probably the most important part of this first topic of historical and societal influences. So looking at this, construction and processing materials used in civil structures over time. The very first ones used was timber, used in earliest bridges, originally used in natural states or a tree. So you would just drop a tree down and that could be used to cross a small river. Offered ease of manufacture and was a readily available resource. That was the number one reason why timber was used for most early civil structures, because it was so readily available. The biggest downside though is timber rots away from moisture or other reasons, and it can also burn, which is another key issue to address. Rope is another one used for early suspension bridges. However, it does rot away and can only carry small loads because the tensile loading of a rope is not relatively that high. Also, rope can also burn. Stone, far more permanent than timber or rope. It doesn't corrode or doesn't burn. Many Roman arches were made from stone and still stand today. Strong in compression but weak in tension. Perfect for arch bridges and also readily available, hence why it was used for early Roman arch bridges. Moving forward from stone were the use of bricks. Similar properties to stone but manufactured from clay and not chiseled to shape like stone, so it's relatively easier to use. Then we move over to the first metals, which was cast iron, readily available during the Industrial Revolution, weak in tension but strong in compression, can be melted and cast, advantage over stone. Bridges can be made from frames, provide strength equal to stone but greatly lighter. But a key issue with cast iron is that it does corrode relatively easily due to exposure to moisture. Hence, the bridge's life would not be, or the civil structure's life will not be that long and would require a lot of maintenance. Moving over to wrought iron, used in early suspension bridges, change which suspended the deck. That's what the cabling was made of, wrought iron. Unreliable due to the fibrous structure present in ferrite, which weakened it. So, it was, again, not ideal. Hence, we move it to steel, change bridge designs to the steel arch bridges, equally strong in tension and compression compared to stone and cast iron. So, overall, it's a much more advanced material. Steel cables were essential in suspension bridges for greater spans to be achieved. And then this led to the development of pre-stressed and post-stressed concrete. So steel was used to reinforce concrete and make it either post or pre-stressed. So therefore improving the mechanical properties overall. So hence we move over to concrete, which is weak in tension, but only used when reinforced with steel. Pre-stress and post-stress improve strength and performance, the bridge construction material of the 20th century. And a key example of the use of concrete is, for example, the metro line that was made. All the bridges used for the metro line were made of concrete and had reinforced steel in it as well, which accounts for both the compressive and tensile forces needed for its key requirements. In regards to construction processes, piles used as a foundation for bridge pillars, rivets, main methods used to join metal bridge members, replaced with bolts and welding. Bolts and welding were a key reason for corrosion to happen at those points. So again, engineers considered this and resulted in rivets instead. Caissons, permanent watertight structure used to excavate deep bridge piers, and then coffer dam is just an example of temporary caissons used in shallower areas. So those are the key material developments over the time. As you can see, we've gone from timber and stone, which were the most readily available materials back in the day, to more advanced materials such as steel and concrete, which is used pretty much everywhere in the modern world. So that's all that we need to know for this first topic of historical and societal influences. And again, when it comes to questions related to this topic, it's relatively easy to answer because they're all usually 2 to 3 markers. And you can simply write in dot points and be as direct as you can in your answer. For example, if a question asks, explain the changes or the innovations in materials used in civil structures, and it was a 3 marker, you could give 3 different materials and explain the difference in the 3 across time. So start off with timber, and then you could go to cast iron, and then go to concrete. And then again, you would start off by saying timber was used in the earlier stages because it was easily available to use and easy to cut down and use in multiple different purposes. Then we go to cast iron, again, easy to manufacture, but a flaw was that it corroded relatively easily. And then we go to concrete, which is probably the easiest to make, easiest to mine for materials, and then has incredibly high compressive force loading. And to account for the tensile forces, we can reinforce it with steel, and it's the most abundantly used material in today's world. So that's all for this video, talking about Module 1 civil structures and the first topic of historical and societal influences. In the next video, we'll cover the next topics of this first module. Thank you.